Welcome back to the workshop once again for another example in power series where we want to find the radius and interval of convergence. Again, we start off by determining where the power series is centered. So, power series is centered at C equals 0 in this case. So it is centered at C equal to 0 in this case. Our next step is to determine the radius of convergence. And we will continue using the ratio test to determine that. So radius of convergence. So we want to take the limit as n goes to infinity of u sub n plus 1 divided by u sub n. And of course we want the absolute value of that. So in this case, we're looking at the absolute value of, take the n plus 1th term, so 3x to the n plus 1 divided by, we've actually got 2 times n plus 1, and we're taking that factorial, and then we multiply by the reciprocal of u sub n, so that would give us 2n factorial in the numerator and 3x to the n in the denominator. And we want to find the limit of this. Now, there's going to be some cancellation here. So what we want to recognize is that when we distribute the 2, we get 2n plus 2 factorial. So that's 2n plus 2 times 2n plus 1 times 2n factorial. So we're left with 2n plus 2 and 2n plus 1. So this is equal to the limit as n goes to infinity. Let's see here. The 3x to the n plus 1 and 3x to the n will reduce to just 3x in the numerator. And in the denominator, again, the 2n factorial will cancel in the numerator, and we'll be left with 2n plus 2 and 2n plus 1 in the denominator. Of course, I need absolute value still. The only thing that the absolute value really applies to is the x, because 3, 2n plus 2, and 2n plus 1 are all positive. Excuse me. So that's the absolute value of x times the limit as n goes to infinity of 3 divided by n, 2n plus 2 times 2n plus 1. But that limit is 0. So we've got the absolute value of x times 0, which is just 0. And 0 will always be less than 1, no matter what the value of x is, because our expression does not depend on x. So the radius of convergence, so I suppose we should say, then by the ratio test, the series will always converge. So you might say that it has an infinite radius of convergence. Some texts might even say that this notation is appropriate. Some might not, because infinity is not a number. So this is perfectly acceptable in my opinion. So we'll keep it with that. The radius of convergence is infinite. And we can say then, since there's no endpoints to test, right? 0 plus infinity is infinity, 0 minus infinity is negative infinity. So we're not really getting any endpoints to test there. So we have the interval of convergence. And that's it. Radius of convergence, interval of convergence. A little bit shorter example, not having to deal with testing the endpoints. So that's always nice. I'll see you guys back in the workshop again soon for another example. But in that example, we will not determine the radius of convergence. I'm simply going to state what the radius of convergence is rather than determining it to help save a little bit of time. All right, I'll see you guys again in the workshop very soon.